Graphing one-variable inequalities. Before we graph one-variable inequalities, we need to learn two things. We need to make sure that we know what the various inequality signs mean, and we also need to know what a number line looks like. So, inequality signs. These are all true statements that we can make with inequality signs. So here we have, when we compare 3 to 2, 3 is bigger than 2. 3 is greater than or equal to 2. It's not equal to, but because it's greater than, it works. And 3 is not the same thing as 2. You cannot make a statement with an equal sign, a less than, or a less than or equal to sign like this. 3 is greater than or equal to 3. 3 is less than or equal to 3. And 3 equals 3. These are all true statements. Now, you're usually going to just see this one, but that bottom line means or equal to. So 3 is less than or equal to 3, and 3 is also greater than or equal to 3. That's what the or equal to sign means. It means that it's greater than or it's equal to. Because it's equal to, it satisfies the statement. Now, 3 is less than 4. 3 is less than or equal to 4. It's not equal to, but that's okay. And 3 is not equal to 4. So those are what our inequality signs mean. The equal sign only has one meaning. The greater than, and the less than signs only have one meaning. And then the others each have two. Greater than or equal to works for equal or greater. Less than or equal to works for less or equal. And not equal to works for anything except for equal to, meaning less or greater. I've heard students jokingly say, what about a less than or greater than sign? Well, less than or greater than is the same thing as saying not equal to. So that's what's in purple. So the ideal number line is straight. It has at least 2 labeled points by tick marks, has all tick marks evenly spaced physically and by common difference, and is labeled to represent a particular variable. So an example of what this looks like is we have a number line. It is straight. We want to have some evenly spaced tick marks. I'm eyeballing it, but ideally you'd have a ruler or graph paper. By common difference. Common difference means that, okay, if this is 0, and this is, say, 6, then the next number has to be 12. Once you pick these two, then everything else is fixed because it has a common difference, meaning we're going up by 4 anytime we go to the right. The positive direction is always to the right, and the negative direction is always to the left. And this is what I mean by labeled to represent a particular variable. The label always goes on the right, even if the number is not positive. All right. So, to graph an inequality, these are the big steps for this presentation. Draw a blank number line, labeling any points you care about and the variable you're graphing. If the point is a solution, meaning equal, greater than or equal to, less than or equal to, draw a closed dot. Otherwise, you'll draw an open dot, not equal to, greater than, or less than. Test a point in each region. If that point works, you'll shade all of that region. So, what does this look like? So, let's make our number line. We need y as our labeled variable. We need to have -3 on here. I'm going to go with 0, -1, -2, -3, -4. So my common difference is 1. Because of that, it is a closed dot. This one will be open. The easy way to remember is that if there's this line at the bottom, then it will be closed because that's the or equal to part. The closed dot means this number works, and -3 is less than or equal to -3. Now, the numbers that work here are -4 is less than or equal to -3. So the numbers smaller than -3 work, meaning the ones on the left. Here, we'll also draw a number line. Let's go with 5, 5.5, and 6. Those are equally spaced because these are these are 0.5 apart. These are 5/10 apart, so they're the same. We already said that this is going to be an open dot. And then 5.5 is less than p. Well, 5.5 is less than, say, 6. So the numbers over here will make it true. Please note that this is the same thing as saying p is greater than 5.5. These are the same statement. When you flip the terms on the left and the right, you have to also flip the inequality sign. So x is greater than 18. We need to have, say, 16, 18, 20, 22. This is x. That makes it open. And then shading to the right, it's shaded to the right because, say, 20 is greater than 18. That's a true statement. 2 is less than t. 2 is less than t. So let's go by ones. -1, 0, 1, 2. This makes it open. And t is the larger piece here. If I put in 2 is less than 1, that's a false statement. So we know that this side isn't shaded and the other side is. Q is greater than or equal to -3. So let's go with -5, -4, -3. Q is our variable. We're saying it's greater than or equal to tells me it's going to be closed dot at -3. And then Q is greater than or equal to tells me I'm going to be shading to the right. All right, that's how we graph one variable inequalities.